started. My name is Joshua, and I'm here to present Universal's NLP project, which is a language identifier that supports 11 languages: English, French, Italian, Romani, German, Portuguese, Mandarin, Vietnamese, Arabic, Dutch, and Spanish. And if you were to input any of these languages, we would have an accuracy of 98%. So right now, we're just gonna do a demo right off the bat. So if anyone speaks any of these 11 languages and wants to send anything into the chat, I can test it out. But for the time being, I'll just test out some of my own things. There you go. That one works. This is going to be French. There you go. All right, let's move on.
This design is remarkable. Who did this design?
It was a whole team effort. So one of the things that our TA stressed is that he didn't want one person doing the whole job because that would result in other team members not getting the experience. So each of us worked on a page and we all combined it together.
Yusuf is great, isn't it?
Yeah, he is.
Wait, these are the languages you guys spoke? Wow.
Yes. So this actually is very clear. Our motivation is the fact that our team's multilingual. Each of us know at least 2 different languages, if not more. So we know English, Spanish, Vietnamese, Chinese, Arabic, French, German, and Dutch. And we thought it would be an absolutely great idea to let you see what it looks like written by having the computer tell you what it is.
Did Yusuf actually taught the class in German?
I speak German. I speak a little bit of German.
I mean, did Yusuf actually taught the class using German?
No, he didn't.
Oh, okay.
All right. English.
Just curious. Yeah.
So our data set consists of 9.7 million sentences that span over about 400 different languages, which we chose 11 of. We prepared our data set by creating thresholds for the limits of how long or short the sentence could be, which brought our data down to 4.2 million sentences. Our first histogram shows, though, that the data set became imbalanced, having a bias towards English. So we had to sample out 50,000 sentences from each to try and even it out. Even with that, we had a total of fewer than 50,000 sentences in some languages like Romani, which we decided to include all the sentences of that language. This is shown in our second histogram, which the final that finally trimmed it down to 455,000 sentences.
So this is the process that we used to create our project. So our first step was to obtain a data set that contained many sentences in many different languages so that we could use it to train our model to differentiate between these languages. And then after that, we removed all the sentences that weren't within a specified threshold and selected a number of sentences from each of our languages that we decided on. And then we split our data into training, testing, and validation sets. After that, we built a list of trigrams from our data so that the model would be able to identify different features in the sentences. And in total, we had about 1,300 trigrams. After creating the trigrams, we needed to count the number of occurrences of each of the trigrams in each sentence to convert them to vectors. And then we also normalized the data. And then after that, we created a model and fed it our training data to teach it to distinguish between the different languages. And we used one-hot encoding to create the expected outputs. And then after training, we evaluated the model using the test data. Finally, we needed to release our language identifier to the world so that other people can use it. And to deploy our project, we used many tools such as HTML, CSS, JavaScript, and Flask.
All right, so to elaborate on our model structure, our model was based on a multi-layered dense neural network with 3 hidden layers consisting of 500 neurons each. And our input was a vector of 1391 dimensions and an output of 11 dimensions or languages. To build our model, we utilized the module Keras from Python and built it using sequential and dense layers. The optimizer we chose was Atom with a cross entropy loss, which resulted in a test accuracy of 98%.
You have another 15 seconds.
So after we were done training the model, we used our test data to evaluate its accuracy, and the accuracy turned out to be above 98%. We also used a confusion matrix shown at the left to help us understand and compare the accuracy of the model for different languages.
And during this project, we learned a lot about how to create such a project using Python and also its many tools with the Python modules like NumPy, Pandas, Keras, and Matplotlib. We also learned exactly how code leads to AI and what AI really is. It's not just a smart computer, but one that imitates human behavior. We also learned that it's not easy at all to teach a computer to understand human language with all its nuances. And these are the team members. I'm Shane. This is Ella. And
All right, thank you guys so
This-
much for listening. I will send the link in the chat for anyone who wants to try it out.
Can we give them a round of applause, a big one, please? A big one. You know what's special about this whole thing? At some point I was like, how does this thing work? I actually don't know how does it work until they talk about the model structure. It sounds like you guys build your own models, right? Using carriers to like essentially construct that model yourself. Is that correct?
Yeah, that's correct.
Wow, look at that. So
Yeah,
that's
I think this product is amazing.
that's amazing, right? That's a special thing. If I were you guys, who are, like listening to that, you'd be like, can I have that code? Like, how do you do that model, right? You got to get their code, because it looks like they just, create a whole bunch of dense layers and somehow got to work. I think they just brute force the whole thing together, which is kind of amazing as well. Yeah, that's awesome. Okay.
I have a question. I saw for your data, you split it into testing, training, and validation. What's validation?
You're saying what's validation data set? Tyler, is that right?
Yeah. I'm aware of what testing and training is, but I do not know what validation is.
Anyone knows? Can someone explain? Okay, so the way to think about it is validation data sets like this. So imagine you're at a school, you're learning a bunch of stuff, right? And so the data you're learning with is essentially the training data set. Okay, and then sometimes before the final test, which is you're only gonna see the final once, you're not gonna see multiple times. That's essentially a test data set. But in between, your teacher would be like, do they actually learn anything? Let me give them a quiz, right? And then after a while, they learn a little bit. Oh, let me give them another quiz, right? So that quiz is basically your validation data set.
How does that differ from testing?
So the validation data set, when you think about it, people are using the results from the validation data set to see whether I should stop training or not, right? Whereas the testing is only the last mile, like the last one.
Yeah. In addition to that, validation is used for hyperparameter tuning. So if you're familiar with what hyperparameters are, if you talked about that in NLP, then that's one of the main points. So you tune to your validation set, and then you only see the test set at the end. Because otherwise you may end up tuning your validation set too much, and then it might effectively reduce the loss on the validation set, but you may actually have high loss. That's what the test set is for. So yeah, that's like a rigorous way of saying it, but yeah.
Yeah, that's right.
Gotcha. Thank you.